الله يخليك دكتورة، الله يوفقك.
السلام عليكم دكتور حيدر، دكتور أمجد.
عليكم
بالتوفيق
السلام.
إن شاء الله
دكتور رائد
والجميع الحضور.
عليكم السلام دكتور.
نرحب بروف حسين اللي كان حقيقة مفخرة والداعم الأول لجميع الطلبة العراقيين والأجانب، ورفعت رأس العراقيين جميعا إن شاء الله. حياك الله دكتور.
يا
جامعة التكنولوجيا، حياك الله دكتور.
الله محييك. شلون حمودي؟
الله يحفظك ويبارك بعمرك دكتور، يحفظك، يعطيك الصحة والعافية إن شاء الله.
تمام. يسعدني ويشرفني. أنا دكتور أمجد، مدير شعبة البحث والتطوير في الجامعة التكنولوجية، تابعة لمكتب السيد المساعد العلمي في رئاسة الجامعة. نرحب بالأستاذ الدكتور حسين القيم من جامعة بترونايس ماليزيا لإلقاء محاضرة علمية ضمن سلسلة محاضرات برنامج الأستاذ الزائر الخاص بالجامعة التكنولوجية. دكتور، أتمنى من حضرتك دكتور حسين تفضل أنه تدير الجلسة من قبلك. The session is yours.
Okay, thank you so much, Dr. Amjad. My greeting to Dr. Ahmed Al-Ghabban and Dr. Haidar, and to you and everybody participating in this presentation. In fact, we are going to learn from each other through a discussion after the end of the talk. And my talk for today is focus on the transition of the energy of the current scenario to tomorrow scenario. And all this transition is going to be manipulated by the topics of the Industrial Revolution 4. So we cannot proceed talking about the energy of tomorrow prior to get an idea what is the Industrial Revolution 4. To know Industrial Revolution 4, we have to go through the Industrial Revolution from the beginning until today and the future. So it's my great pleasure that University of Technology organizing this set of or program of visiting professors and presentations through the online. And I am Professor Prof Al Kayiem. In fact, I am graduated from University of Technology. So I am part of this university. When I graduated, it is formally named as College of Engineering Technology, as one of the university college under University of Baghdad. After my graduation in '73, after 2 years, I think it's converted to a University of Technology. My specialization is thermofluids and energy technology, and currently I am heading the center, which as I established by my effort and my students' effort. I am so grateful for the support I get from my students who graduated and now they are staff in University of Technology, Baghdad. And this center is called Solar Thermal Advanced Research Center. They have a great contribution to the establishment of the center. And this center is part of the research and development in University Technology Petronas in Malaysia. Where are we? If you can see here, now I am here and you are sitting somewhere in this spot. So all of us are within Asia. I am in the southeast of Asia and you are in the mid-east of Asia. And enlargement, in particular, I am in this spot, which is named Perak. My city is named Perak. And now I bring my students to remind them where they have been living before. Somewhere Raed is living here, and Sundus somewhere here, and the others surrounding the university. So this is the university. And our center within the university, last time it is, where is the swimming pool? Here. This is our center last time, and then we shifted to a new location somewhere in the jungle. And we have getting this spot to be our center. Looking from the Google to the center, this project is designed and fabricated by Dr. Sinan. He is doctor in Ministry of Electricity in Iraq. This is the heliostat and central tower project designed and fabricated by Dr. Ayad from University of Technology. And this is the solar vortex engine, which has been shifted from the old site to the new site by Dr. Ali Abdul Wahab. And this is the solar chimney power plant model, which has been utilized by Sundus and then Dr. Muhammad Arabi. And here we have the PV project. This is the PV project, in fact. We are covering our postgraduate office by PV plant, 10 kilowatt power plant. But here we have development project in collaboration with Munich Technical University, and also the student work on this she is from Iraq, from Ministry of Electricity, Mayamin, and Dr. Hassanian assist in the establishment of this setup. So this is our center, and here we are. This is our office, and this is our postgraduate office. Our center doesn't consist that large number of staff. I am the head of the center, and Dr. Jundiga is my deputy. And we are splitting ourselves into two teams, solar systems and thermal systems. The niche area, we are working on cleaner energy technology, which is under the national priority in area of Industrial Revolution 4. And our research direction is split into two parts: solar energy systems and thermal energy systems. And we are working on solar power generation, thermal energy storage, enhanced heat transfer, solar thermal utilization, water desalination, and mostly we are distinguish ourselves internationally by working on integrated solar technologies. We try to solve the problem of the solar technology by integration. And Stark mission is to upraise the solar to be the king of the energy mix to mitigate greenhouse gases crisis and for improving the poor communities. That is a background, and I come to the flow of the presentation. It is going to consist of three different parts. I will start with the Industrial Revolution and what is Industrial Revolution for. Then we come to discuss together the energy contents under Industrial Revolution and Sustainable Development Goals of the United Nations. Then we move to the scenarios of energy. How is it today? How is it going to be tomorrow? So mostly we are focusing the talk here. Then we come and see how the solar can participate and solve this problem and be a big mix of energy of tomorrow. Let us start with part one. And now everybody talk about Industrial Revolution 4. We cannot understand Industrial Revolution 4 unless we go through the history of the Industrial Revolutions. So let me go from Industrial Revolution 1 and where are we now? We are here. About 200 or 300 years before. Industrial Revolution 1 started in the 1076, 760 until the 1840. During this time, there is a shift from the human and the animal utilization in the production to utilize the steam. So the power of the machine is operated by steam and hydro. Then it is moved to the next Industrial Revolution 2, where the electricity takes place and the mass production in the factories controlled by electricity and motors. Industrial Revolution 4 distinguished to Industrial Revolution 2 by the electronics and the computer utilization in the mass production. And there is a report as well. Now the difference between the Industrial Revolution 3 and 4, which we are experiencing now, that in Industrial Revolution 3, there is a computer but it's connected to the machine through wire, direct connection. Or even if it is wireless, there should be a sensor and receiver to receive direct signal. And the Industrial Revolution 4, the internet control everything. And the mobile is the master. The mobile, which we are holding in our pocket, is the master of the mass production. And this is the strategy of Industrial Revolution 4, that everything should be controlled by the mobile. So what the key technological development in those transition of technology and when it's happened? So this is the dates, and we are here now, transition from IR3 to IR4. Again, I would like to explain that the change from human and animal labor to steam and hydropower, this is represent the Industrial Revolution 1, and it is mainly on the textile. And it is started in UK, in particular in York. And if I go specifically, it is in Bradford, where I get my PhD. So the Industrial Revolution 1, it started in somewhere where I live, and I have seen some factories from this time still existing there. They are not working, but the establishment is there. So here, from the use of the animal and the human to the use of the steam and hydro. Then Industrial Revolution 2 took place when the electricity became the master of the mass production in the factories. So the electrical operated machine for mass production. And this is developed with the development of the PC and the computer. And then we have the electronic and the computer in this Revolution 3. And now we are here, a transition from 3 to 4. So what's going to happen here? As I told you, the master is going to be the mobile through the internet. So we are changing from electronic and computer online connected production lines to intelligent digital remote control production. And this is the main theme of Industrial Revolution 4, Internet of Things. The internet is going to be the master, and the tool for your internet is the mobile. A simple example is the grinding of crops. If you remember this, some of our grandmothers, I have seen this. And in my city in Hilla in Babylon, I have seen this, and the people use it for the grinding of groups. So this is before the Industrial Revolution, how the people grind the groups. And then what's happened? The people started to utilize the hydropower and steam to operate the grinding machine. So from the hand and animal use to the hydro and steam. After that, we have this grinding machine operated by a motor, electric motor. And this electric motor took more than 100 years to be the master of the mass production in the industry. And then if you look to this line and compare with this, this is computerized. And there's a computer control the operation. And if you look to this bag, there is a sensor which can send a signal to the computer, and the computer stop the feeding of the grinded group to the bag. So there is something like a control and operation. Here, there is no control operation. In Industrial Revolution 2, under the mastering of the electric motors, there is no control as we know it nowadays in the mass production. Now the grinding machine, even it is developed furthermore, and you can operate your home grinder while you are in the office coming back from after work at 5 o'clock, and you set an order to your machine to grind and prepare for you your coffee. How you connect this to this? It is through the internet. So there is no direct connection in Industrial Revolution 4. And this simple example doesn't apply only on domestic use or home use, but also for the industry in a very wide scale. This is the master and the future of the industry. Now, the difference between Industrial Revolution 3, there is a direct connection between the computer and the robot. Yes, there are robots and there are advanced robots and there are sensors and actuators to sense the product, but there is direct connection, as you see here. In Industrial Revolution 4, all this is gonna happen not through a wire or signal, direct signal. It's gonna happen through the internet. And everything is through the mobile. So this is the digitalization compared to the electronization. In Industrial Revolution 4, we are digitalizing everything through the Internet of Things. Okay, so in Industrial Revolution 3, automation using digital computer and ICT features, and this enhanced by adopting intelligent feature and wide involvement of the internet through the mobile. So here we have Internet of Things, cloud networking, big data analysis, mobile device control, and the smart sensing, and the IT. Right, what are the core concepts of this coming revolution of the industry, which we are experiencing the beginning of this industry now? Of course, all of us, we know that in China, they have gone very advanced step in IR4, and the rest of the world is following China's steps to be part of this industrial revolution. But China is the leader of the industrial revolution due to the high development of the artificial intelligent technology in China. However, those are the concepts. IoT, or let me start from here, IRP, Enterprise Resource Planning. It means that the business process management tools that can be used to manage information within the organization or the association. Internet of Things means, or it means a concept that refers to a connection between physical object, machine, or product, like sensors or machines, and the internet. Industrial Internet of Things, this is a concept that refers to the connection between people, data, machine, storage, and the related issues, everything to the, even the transportation, everything related to the manufacturing. The big data is a large sets of structured or unstructured data that can be compiled, stored, manipulated by researcher, manipulated by the industry, and clustered, classified, and analyzed to reveal some pattern for the future, a trend of the future, association, and opportunities for the people, and mainly under the sustainable goal development for the poor people. And what the United Nations trying to do is to prevent the deviation between the developed and the third world country and this technology. They want everybody to have opportunity to access to the big data analysis. Artificial intelligence, all of us are familiar with this abbreviation, which is a concept that refers to computers' ability to perform tasks, not the human being. The computer can work as a brain, can analyze data, and can make a decision. So this is the artificial intelligence in the industry. And M2M is the machine-to-machine, meaning that communication that happen in the production line between two separated machines, maybe in two factories, maybe in two separated lines. So this is communication between machine to the machine, and it is very smart communication through the internet. And the digitalization refers to process of collecting and converting different types of information, either to pictures, to data, alarming, and so on. All of them are in digital format. And all of this transformation of data and communication is through the internet. The internet is going to be the master of everything in the future. One of those is the energy. I will show you. And we have the cloud computing. And the cloud computing and the machine learning, I don't want to spend more time. And those are the features or the core concept of the new industrial revolution, which started already now, and we don't know what's going to happen after 10 or 20 years. This is about the industrial revolution, which I found it necessary to be presented to link between the energy of tomorrow with the industry. And in fact, we cannot link those, the energy and IR4, without go through the Sustainable Development Goals. What are the Sustainable Development Goals? They are the 17 targets set by the United Nations, the Industrial Development Organization. And those goals have a beautiful aims to resolve or to target development of 5 Ps. What are those 5 Ps? People, planet, the earth, prosperity, peace, partnership. So those 17 sustainable goals are targeting melting or destroying the barriers between the poor and the rich, between the north and the south, between the west and the east, between the developed and third world countries. It is a big goals, and hopefully that all of us are struggling to meet those 17 goals, and everybody as a researcher or part of this globe to take place in implementation of those 17 development goals for the sake of the future of our generation, for the sake of our Mother Earth. Now, when I come and talk about the energy, I can identify 3 goals which are related to the IR4 and the energy of tomorrow. Those goals are a clean energy under SDS 7, sustainability under SD 11, and climate change. Those are highly related to each other, highly related to IR4, highly related to the change of energy scenario. So those are 3 goals are aiming clean energy for tomorrow under IR4, and clean energy can mitigate the major challenge which we are facing, or all the globe facing, or all the 9 billion people are facing in the globe. Industry 4 can contribute to development or creation of new ways of dealing with major global challenge. I think all of us are familiar with the challenge which we are facing now. Climate change is number 1. Lack of clean energy access. Not everybody has access to clean energy. And economic stagnation, you see that each 10 years we have economic crisis which affect all the economy and the development in the world, and reducing the digital deviation between the poor and rich countries. Those are the challenge which the Sustainable Sustainable Development Goals and the United Nations try to resolve through Industrial Revolution 4 and Energy of Tomorrow. The 7 goals are here, 7 and 9 and 13. This one for clean energy, and we know that the renewable energies are the best representative of the clean energy. And sustainability, what is this, sorry? Industry, innovation and infrastructure. Yes, sustainable industrialization, sustainability, and increase access to the information by all the population, and the climate change. So we are looking for mitigation of the climate change. Those 3 goals are highly interlinked to the Industrial Revolution 4 and the Energy of Tomorrow. So under those 3 Sustainable Development Goals, I can say those 3 Sustainable Development Goals are not to be approached in individually or in isolated way. They are interrelated to each other and exploiting the benefit of a new technological development in the energy sector. Every sector, but now we are talking about energy and area of information and communication. Those could help to tackle those sustainable goals in an integrated way, not separated way, and to contribute significantly to sustainability and decarbonization. Now this is the big abbreviation, decarbonization. Decarbonization can interlink those 3 goals, and I will show you how this decarbonization interlink all of them. Decarbonization is our aim, and the aim of every strategic planner, every investor, any developer. So, how to reach this decarbonization? From this part, we can conclude that we cannot separate Industrial Revolution 4 from the Sustainable Development Goals of the United Nations on shaping of the energy of tomorrow. So we have this abbreviation, we have this abbreviation, we have this abbreviation. IR4, Sustainable Development and Clean Energy. Those will contribute to the energy of tomorrow, or the theme of this talk. Then we come under those 3 categories, or 3 manipulations of those will lead us to decarbonization and climate change. This is the main goal. Climate change through decarbonization. Decarbonization and climate change. How is that? This is the theme of the talk. Decarbonization and climate change can be achieved by clean energy. How? How this possible? So, why we want to change? We have energy. We are generating electricity. We are generating power. And we have resources. We have fuel. We have gas. We have petrol. We have coal. Why we want to change the scenario of today production to another sort of a production? Let me go and share with you some data or information on the global energy demand. In 2016, if I'm not mistaken, yes, my data up to 2016, and then there is extrapolation until 2050 and 2100. The estimated energy required to run our lifestyle and the development of our lifestyle is around 25 to 30 terawatt. 25 to 30 terawatt. In 2016, the Earth utilized 16 terawatt of energy. The need for the Earth to run the life, it requires 16 terawatt in 2016 here. And this is the expectation in 2050. And 2100, this figure is doubled to go up to 40 or to 50 terawatt. This is not a joke. This is a huge challenge. This is a big challenge. How to solve it? Now we are producing our power based on oil, gas, coal, and nuclear. If we say that the nuclear is clean because there is no pollution and there is no CO2 emission, I am personally, as a futuristic energy scientist, I believe that the nuclear has a huge pollution in the future, because how to deal with the waste after utilization in the plant. Yes, you produced energy, but after that you have a very harming waste. What to do with the infrastructure of the nuclear power plant after 50 years? What to do with the nuclear waste? However, the people, they consider it, since it's operate without CO2 emission, they consider it clean. What are the dirty resources? Oil, gas, and coal. And unfortunately, we are producing 85% of our energy based on this dirty resources. With the current scenario of what we have as resources, oil, gas, coal, nuclear, and renewables, if we increase the utilization of all of them, we can reach a production, which means the demand, but we will have a gap of about 14 terawatt in 2050, and this gap increase and will create a huge problem, maybe wars. Yeah, there are wars, and this is the reason of the war in the Gulf, all of it because of the resources. So this gap is going to be increased to 33 terawatt. Now, how to solve this? This is a huge challenge to all the strategists and the investors and the banks and the developers in the world. From where we bring the 14 and 33 terawatt to meet the demand of the Earth for energy. Then we can say that the global energy production is dirty, as there is 85% produced by fossils, and the demand is less than the production. So there is a huge gap, and there is carbonization. When you are using 85% of your sources emitting greenhouse gases, then this is carbonization. But the aim is decarbonization. How? Why we are changing the current scenario? Now, unfortunately, not Iraq. I am not talking about Iraq. But everywhere else in the world, there is no shortage in the resources, as we have fuel and we have coal and we have gas and we produce energy. So what's the problem? Is it shortage of depletion of existing resources? No. There is a huge amount of resource of fossil fuel. What is the problem then? Is it with the production and the power plants, or the decarbonization? In fact, the United Nations, Europe, Australia, Canada, all of them, and now US returned back to the correct line. All of them are looking for decarbonization. So the change of the energy from the current scenario with 85% fossil to new scenario is here. This is the motivation. We need to change everything because we want to eliminate CO2 emission and we want to stop the carbonization and GHG emission, greenhouse gases emission. So now this is why. But why the people blame the energy? Always there is blame for the energy in production of CO2 and pollution. Why not other industrial processes? Why the energy? We will see why. I would like to present to you the huge increase in the carbonization on carbon CO2 emission, how it's increased in the last 150 years. So if you look to the figure, in 1850, it's about 5,000 million ton of CO2. Now this figure comes to around 50,000. If you look to the trend of the increase because of the industry, is this. And the projection for the future, we expect an increase. There is no stabilization unless we stick to the new scenario, or we have to change our way to produce energy. So this is the CO2 emission. And when we come to the temperature, or we say global warming, everybody talk about global warming. It's true. Some political say, no, that is just something not existing. It is existing. This is the surface temperature within about 50 years. You see there is an increase in the surface temperature of the Earth about 1 to 1.5 to 2 degrees. And this is not a joke. This is a huge. This is going to do a lot of change in the Mother Earth. And if we go deeper in the history and we look to the the CO2 emission and the global mean temperature, if you look in the last 150 years, there is a huge increase in the carbon emission and the ambient temperature. It's about 1.5 degrees as a mean of an increase in the last 150 years. And we see that the CO2 also, as I have presented previously, it's increasing exponentially. Why the energy blamed? I tell you why the energy blamed. Because the dirty gases, the greenhouse gases emitted, if we say 100%, 82% of them is CO2. The rest another type of gases. But 80% of the emitted greenhouse gases is CO2. This is why the people always mention CO2, CO2, CO2. And they blame the energy. Why they blame the energy? If I bring this 80% here, the energy produced 72% of this 80% from the energy. When we produce the power for our electricity, for our fridge, air conditions, lighting, and machines, so it is 72% produced by the energy. The rest are another resources for the CO2 emission. And this is why the people think that we have the current scenario of the energy production. Current energy production scenario emits greenhouse gases, mainly CO2. And this is causes global warming. What is the scenario of today? I think all of us are very familiar with the current scenario, which is dirty. Today, energy scenario is dirty as it is based on thermal, and all of us producing the energy from steam power plant, gas power plant, coal-based power plant. So we are producing the energy in the thermal power plant by coal, gas, and oil. And when you have 100 units of coal or gas and oil you produce about 40% as energy, useful energy. The rest go as waste. Waste in the emitted flue, the thermal waste, and waste as CO2. More than the half of the used resources go to the ambient as pollution. This is why I name it dirty thermal. Now it is the king. All our production, or 85% of the production now, is based on this scenario. Now you produce the electricity and you transmit the electricity through high kV lines, and this is another story. The high kV lines also, they are dirty because they are causing a lot of electromagnetic emission, which cause healthy problem. Then the high kV lines, before reach the end user, they are reduced to a smaller kV for utilization in the industry, and another reduction to reach 250, 220 volt to be utilized in our industry, homes, schools, universities, lighting of the streets, and elsewhere. So this is the current scenario. From this dirty until the end user. We are the users in our homes. Now you are sitting and you are operating your PC based on this scenario. You have light based on this scenario. If we continue with this scenario, then we keep increase the CO2 and greenhouse gases, and we damage our future. We will damage our mother care, and we kill our new generation. To transit from the current scenario to tomorrow's scenario, there are points of departure. You have to put those in mind when you are talking about changing. And they are a huge challenge. You are going to move from centralized production in the thermal power plant. And when you move from the centralized power production and their investors, how to do with the banks, which they are making money from this dirty thermal power plant? What about the investors, the billionaires, and so on? The Seven Sisters, how you are going to challenge the Seven Sisters who are producing the coal and petrol and gas and controlling this energy production? So this is a first challenge. Then see the current infrastructure, what to do with them? We have a huge cabling grids, high kV, and the towers. What to do with them? They will be waste. Gas pipelines, grids, the thermal power plant structure, substations, district heating and cooling, and so on. All of those are representing huge money to those people, the investors. So when we move from today to tomorrow, we will have, or we will face a challenge by those. Fuel transport business, the tankers, the storage, the pumping station, and so on, for the gas, for the petrol, for the oil, for the coal. And consumers' mindset, we are the people. Are we going to accept it that we are producing energy not from thermal power plant? I put PV on the roof of my house and produce energy? Some people will not accept it. Some people don't like the noise of the wind turbine, for example, and so on. So the customer mindset is another challenge. And what to do with the jobs? Now you have millions of people working on this thermal power plant and the transportation of the resources and the transmission of energy, and so many. So what to do with the job? This is another challenge. I move to the tomorrow energy scenario. And the leader, frankly speaking, the leader to this change is Germany. Germany now convinced the United Europe to go toward this change, toward the clean variety mix of energy. And here, when you are talking about clean variety mix, then the thing come to your mind, the renewable energies. The renewable will be the source for the clean variety. So instead of having thermal power plant, we will have centralized, mainly biomass, wind, solar, geothermal power production. And we are going to produce this in our farm, in our factory, in our home, in our village, and we sell to the network. So instead of having the current scenario coming from the thermal power plant, we will eliminate the thermal power plant, then we eliminate the use of the coal and gas and oil. There is no high kV. There is only medium kV lines and the low kV lines. So instead of producing from here and transmit to our use, we will transmit. We are the people. We are the farmer. We are the small industry. We are the schools, the universities. We will, in the future, produce the electricity and we use it for our demand and we sell to the network what is over demand. So this is the future scenario. And now Europe started to implement this. Russia started to implement this. I have a similar presentation to this, and my colleague in Ural Federal University, they told me this. They are copying Europe lesson or Europe plan. Then when you want to move from centralized to localized, this is centralized power production. This is localized in your area, in your home you produce. You require continuous research and development, and you need to analyze the themes of the Industrial Revolution 4. Here where RI4 comes to assist you in this scenario. You need to implement smart transmission, smart monitoring, sustainable resourcing, low-cost conversion, energy efficiency, and clean processes. And the themes of IR4 will assist you to implement all of those, to produce local energy, and you sell to the grid. What are the challenges? To meet tomorrow energy scenario, there are points to consider. Centralized to localized, meaning you need to focus on standalone power generation. And I think that all my students who are listening now, they have done some research on standalone power generation. And then what we produce in the standalone, we use some and we sell the rest to the grid, small grid. During the production of a new structure, what to do with the CO2 storage and the CO2 transport? When you produce, for example, PV, during the manufacturing process, definitely you are producing CO2. What to do with the CO2 to be clean? Because when we talk about the clean variety mix of energy, we have to think about from the zero, from the production of the equipment, transportation of the equipment, running of the equipment, the waste, and the future of the equipment. In all those stages, we have to think about the CO2 emission, because this is the goal of the transmission from today to tomorrow. You want to go to renewable. This is fine. Beautiful that you are thinking about renewable energies as your resources. But the problem with the renewables mainly the solar and wind, they are intermittents. Solar available during the day, not available in the night. Solar is highly available in the summer, but maybe not available in winter, in cloudy days, in rainy time. So this intermittence also a challenge, technical challenge. We need to think about it. So meaning that when you have this intermittence, that you produce electricity not when you need it, but when it is available. You produce the solar energy, the solar electricity during the day and you use it in the night. How? If it is produced in the day, how we use it in the night? You need energy storage and so on. Now all of those, or mostly, they are technical problems. The big problem is who is going to lead this transition? Who are the people who will implement those plans? I tell you, I have collaboration with Norway and my colleagues in University of Stavanger. They get 15 million euro grant from EU to produce 15 postgraduate students who are representing the leaders of the change game. And those leaders, they are not technical. We are technical. Most of us, we are here. We are thinking about solving a problem here. But those people will look how to convince the investors, the banks, what to deal with the waste, what to do with the community to accept the new change. And so many issues far away from the technical issue. So what we did in our research, in our publication, in fact, falling in here, but we haven't thought about this. But Germany and Europe thought about this, and now Moscow think about it. Again, they copied the plan of Europe. 15 leaders are going to be prepared in University of Stavanger for Europe. 15 leaders are under preparation in Ural Federal University in Russia. So those people thinking about the future, and I have no idea what's going on in China, and I have no idea about US, because the US, they come to United Europe and they want to copy the plan, but they stopped during the era of Trump. What's going to happen now, I am not quite sure, and honestly, I am not following. But they haven't implemented any plan so far. This energy change game is in Europe first, in Russia second, and Australia third. And the rest of the countries, the rest of the world is following up. We have no escape. Sooner or later, we have to follow the scenario. Otherwise, we will not get a support from the rest of the world, the third world countries. Okay. Transition from today to tomorrow energy is a huge challenge, and mainly in this. If I come to the conclusion from the previous 3 sections, I can see that global energy production is 85% produced by fossil, which is dirty. And there is, when thinking about 2050 to 100, there is a huge gap in the demand. How to cover it? This is one. Second, current scenario emit greenhouse gases, in particular CO2. And this lead to global warming. The third conclusion, transition from today to tomorrow energy is a huge challenge and requires a new category of leaders, not technology leaders, not bankers, not investors, not businessmen. A new type of people to think and merge the technology with the economy, with the business, with the community. So those are 15 of them are under training now in Stavanger and 15 under training in Ural Federal University, economy. However, now we have 85% resource from fossil, which is dirty. What are the alternative to 85? Because the United Nations and the strategic people looking for clean energy. We want to eliminate or the emission of CO2. So we have to think about clean energy. No escape, even with low efficiency. But the price is clean energy production. And here we come to see the solar participation in the energy of tomorrow. Can the solar be the king? If you ask me my opinion as a futuristic solar researcher, I say yes. And I have my own reasons. In fact, it is not solar only, or it is not renewable only, it is mix. So no escape from keep using the fossil, but under high efficiency and the reduced and controlled CO2 emission. And we have the nuclear and renewable and the fusion. The fusion under development now, it has not been reached yet. We have to think about all of those resources to be clean and safe. When I say safe, safe during the production of the resources, during the operation of the plant, and after you get the waste from the plant. So all of those are challenge, but we don't have other alternative. Those are our resources to cover the gap of the demand in the energy production. This is the gap. Keep remember this, that we have this gap in 2050 and this gap in 2100. And those are the resources. Can renewable take a lead in tomorrow energy scenario? And what are the restrictions and challenge in going renewables? We are the technical people in the universities. We are thinking of this, and we are doing a lot of research and development on the technical part. But there are another issues far away from the technical. Economy, business, jobs, community, and the global warming, and so many other issues. Yeah, as I mentioned, there is no single solution. Diversity of energy resources is required as what we call it energy mix. And we need to put the solar as the king of this energy mix. Why the solar? If you look to the figures here of the solar, maybe I have another better presentation why I am thinking about solar to cover this gap. I come to this. In 2016, we are the people in the globe. We utilized 16 terawatt in 2016. And this is the size of the 16 terawatt. Look to this size. This spot represents this figure. If I compare this with the solar which we received during the year, this is the size of the energy which we receive on the earth and the surface of the ocean. So it means that hundreds of the requirement of the human being is produced or available from the solar. And if I compare this size of the solar energy with the coal, uranium, petroleum, natural, and the other resources, those are clean, wind, biomass. The solar is huge. The only problem is the conversion. We have low energy conversion, unfortunately. So all of us, we need to think about breakthrough. How we enhance the solar thermal conversion or solar to electricity conversion. If we make a breakthrough, we can resolve the demand, the gap of 14 terawatt in 2050. So solar is the largest sustainable resource of energy to Earth. We need to think about this, and we put this in mind, that this is what we need, and this is what is available from the solar. The other from here. Those are dirty. This is dirty. This is dirty. This is dirty. This is very dangerous, the uranium, in terms of risk of operation and in terms of waste. What to do with the uranium waste. How solar can be converted to induce energy? We have those technologies. We have solar to electricity by PV. This is the PV technique. And we have by solar fuel, by plantation, and we have solar thermal. So those are the technologies of conversion of the solar to electricity or to energy. This is indirect. This is direct. You can generate electricity from the solar. Here, indirect, you produce biomass, then the biomass can be utilized for power production. And you have another technologies, which are the concentrated solar power and the heating by a flat plate collector and so on. So solar to energy, we can classify as low grade temperature conversion, like here, medium grade conversion by something like this, and high grade temperature conversion by concentrated solar. Ali Abdul Wahab, Muhammad Abdul Nabi has worked in this medium grade. Sundus worked in here. Ayad worked here. And let us see their job. The major setback in the solar, the night and the cloudy days, large flat land. We need flat land, not hills and valleys. And the bigger problem, the low energy conversion of solar to electricity. So those are the setback, and we are technologists working to enhance this. Solar to energy, if I am talking about low grade temperature, we have PV solar fuel, and we have water heating, and we have the operative solar power under this medium trend. When we talk about high grade temperature, we have the parabolic trough, heliostat, dish concentrator, and Fresnel reflectors. Those are the technologies how we convert solar to energy. The PV, everybody familiar with the PV. This is the sequence of electricity generation by PV. I don't want to take long time from you on this. And research and development under Industrial Revolution 4 can contribute to enhance all the application of the solar PV. And by solar bioenergy, meaning that with the plantation and the people now working in the labs to produce new technologies, how to enhance the grow of the groups, the grow of the grass and biomass within months to be utilized as biofuel, either by production of biodiesel or direct use in the thermal power plants as solid biomass. So there are many techniques by utilizing the solar in advanced technique, by artificial photosynthesis, by photocatalyst, and by chemical energy, by photosynthesizes. Those are a bit advanced, but I advise University of Technology to go through those because they are the cut edge of the solar energy utilization or the solar energy contribution for solar bioenergy. And I think University of Technology has the ability and the labs which can bring some postgraduate students to start working on this or set programs on these technologies. Okay, solar biofuel, this is the challenge and require development. And I come to solar updraft power, and I have some of my students in University of Technology who have worked hardly in this technique. And mainly we have Sundus and Muhammad Abdel Nibi who work on the solar chimney power plant, where we heated up the ground and we generate steam, operate turbine. And this is the sequence of the solar chimney power plant, which is beautiful. The only problem is the tower. The tower consumes 75% of the initial cost, and it represents a technical problem when we are talking about 1 kilometer height of the tower. So instead of this, we have coming with a new technology. This is what we call it solar vortex engine. We replace the solar chimney by a vortex, and we simulate the tornado in the nature by artificial tornado. And this system originally generated or designed and implemented by IAD, not IAD of technology, IAD of Al-Nahrain, who has designed and fabricated this. Then Ali Abdul Wahab developed this technology by integration with a beautiful sensible thermal energy storage, and he improved the operation of the vortex generator by a new technology. He converted this to be what we call it heat trap, solar heat trap. So a lot of enhancement has been implemented on the solar vortex engine by Ali Abdul Wahab. And now I have another Iraqi student from Babel who is continue the work on this technology. Operational principle of the thermal or concentrated solar power, all of us, we know that the concentrated solar power is based on focusing of the energy on a spot, either a pipe or a spot, where you have the water flow or working fluid flow, and you generate steam or very hot thermal oil. And the aim is to produce steam with higher than 200 degrees centigrade temperature. It will be with high quality, which able to operate a steam turbine. And we have a problem in the concentrated solar power, a lot of a problem. And again, the R&D and the research contribute to the development. Some of our stories and successful case studies, this Hassanian, remember that he has fabricated this, and he integrated with Miami in the ground heat exchanger with the PVT, and we improved and enhanced the operation of the PVT. So this is one of the successful stories. This is another story of the solar chimney, where Sundus developed the solar chimney and later used by Muhammad Abdel Nibi by integration with fuel resource. And we have, oh, this is what Hassanian has done. And this is Ali Abdul Wahab work on this technology what we call a solar vortex engine, where we simulate the tornado from the nature and we create artificial tornado to operate turbine underneath the vortex generator. And this is the secret of, and we are working also on solar steaming, where Ayad developed this technology and he fabricated here a hybrid or mix of technology of tower concentrator. He converted this tower to PVT and evacuate tube receiver, and beautiful. Last month or 2 months, he published his paper from this work, and we are trying to develop furthermore the technology. And we have parabolic trough station, also this designed and implemented and measured by Sinan, who is an Iraqi guy in Ministry of Electricity. He developed this technology and he managed to reach 150-degree steam. Yeah, 150, and I think Ayad reached 159, and now we are increasing the number of the heliostat. We want to reach 200 degrees. So all of those are contributed by University of Technology candidates. We can say that no one single resource of energy of tomorrow, with effort by research for innovative technology, solar can be the king of energy. Yes, it's possible because of the size of the resource. Huge, but we need to improve the conversion technology. University of Technology must work now on this, because I believe the ability is there. For night and cloudy days, we are thinking about integration with other resources, and we are thinking about advanced energy storage technologies. And on the size of collectors and utilized area for energy conversion, solar energy conversion, we can use intelligent tracking system and innovative smart solar material. Here, I think while I am in Iraq in the 90s, in the University of Technology, people start talking about the smart material and the functional material. And I remember I am part of committee with Dr. Qahtan and Dr. Mohammed Tornichi. And I remember the Department of Material and Production talking about this smart material and functional material. And about the new conversion of solar to electricity, again, we have to think about smart functional material, nanotechnologies, and artificial intelligence. So let us move from the traditional or conventional research in the University of Technology and let us start with those advanced technologies. Even we start with the fundamentals, it's beautiful. Just put a ground, challenge, and go forward, inshallah. And with this, I close my presentation. My apology if I extended more than 1 hour. I hope that it is useful for my colleagues and my student and the students in the University of Technology. Thank you so much for your attention. We open the floor for any question or comment.
شكرا جزيلا، شكرا جزيلا دكتور على هذه المحاضرة الرائعة صراحة. Thanks for addressing all these energy production and available resource issues. حقيقة يعني هذه المعلومات القيمة اللي هي صح احنا talk about just topics أو headlines of issues، بس هي كلش مهمة انه احنا draw our attention for the possibilities to use the new technology and union them with the renewable energy, especially with the solar energy. يعني جدا نشكر حضرتك، وخصوصا انا هم يعني الحمد لله الاختصاص مالتي قريب على حضرتك انه يعني sustainable and renewable energy. حقيقة أحب أن أبدأ بالنقاش أو مداخلة. خل أقول إحنا حقيقة ما أثرت حضرتك باختصار استخدام ال IoT في عملية البحث العلمي. حقيقة إحنا كشعبة بحث وتطوير وبإشراف مباشر من قبل السيد المساعد العلمي دكتور حيدر شخصنا أهمية هذا الموضوع، وخصوصا أنه إدارة الأشياء عن بعد، خصوصا احنا اللاب وورك مع جائحه كورونا هو شيء جدا مهم. بالحقيقه احنا تبنينا مشروع السمارت جرين هاوس المستنبت الذكي، وحاليا اندر كونستراكشن، يعني في طور الاعداد اليه. راح يكون اول مستنبت ذكي على مستوى الجامعات العراقيه اللي راح يدير نفسه بنفسه. الفكره هو ليست المستنبت بحد ذاته، الفكره انه نشر ثقافه الاي او تي باستخدام إدارة التجارب، لأنه تعرف إحنا حضرتك معرضين لأي وقت أنه يصير عندنا حظر تجوال، وكذلك متابعة أو استحصال الداتا من اللاب حتكون صعبة جدا. فإحنا شارعين بهذا المشروع البحثي بإشراف مباشر من قبل السيد المساعد العلمي وبدعم مباشر من رئاسة الجامعة أيضا. فالحمد لله إحنا لقينا أكو نقاط matching with you with your presentation، وهذا الشيء يعني أسعدني حقيقة. أنا نعم دكتور.
Yeah, in fact, I have this application in my site. I have 2 students or 3 students. We have established Life Green Wall, and this Life Green Wall integrated with another project for power production. And Life Green Wall, same as the greenhouse. We implemented smart irrigation and smart monitoring of this, which is similar to your greenhouse. So we have it as Life Green Wall. الحقيقة Life Green Wall هو يعني نبات اللي يمنع direct incident of solar radiation on the side walls. If you talk about a green roof, the green roof prevent the solar incident of the solar radiation, the direct incident of solar radiation on the roofs. هذا التكنولوجي إذا تسوون به شوية ريسيرش بالعراق أعتقد تقدرون يعني تنمون فكرة الاستزراع على السطوح.
نعم.
واللي هي أعتقد كلش ضرورية بالعراق، خصوصا بالصيف، لأنه معظمنا بالصيف بالعراق الطابق الثاني اللي معرض السقف مالته لأشعة الشمس قاتل.
نعم صحيح. energy saving.
energy saving. أنا شفت جيران ماي سيستر اللو مسوي هذا المشروع، يعني محول السطح مالته إلى مزرعة.
نعم.
أي بالطالبية. فالحقيقة إذا بديتوا بهذا المشروع مالتكم الجرين سمارت جرين هاوس، هذا تطبيق كلش حلو، وأنا أقدر أتعاون وياكم، لأن قلت لك أنا عندنا هيك تطبيق، يعني ما أعرف جماعة اللي درسوا عندي كلهم يعرفون بلوال كمل لما هم موجودين، كمل ماجستير وهسه يكمل دكتوراه، ويعرفون كالي she implemented the Life Greenhouse. أعتقد كلهم familiar who is Kali. She is my Chinese student. So we have a similar project, and I highly encourage, and I'm happy to hear that you are going toward this type of a project.
Thank you. حقيقة عندنا مداخلة من قبل السيد المساعد العلمي دكتور حيدر، تفضل.
شكرا جزيلا دكتور أمجد. حقيقة أولا أحب أقدم شكري وامتناني إلى بروف حسين على هذه المحاضرة القيمة اللي ألقى الضوء فيها حقيقة على موضوع الأهم على مستوى العالم وعلى مستوى العراق بشكل خاص. والعراق يعاني من مشاكل الطاقة اللي احنا يعني على مستوى الشعبي أو على مستوى احنا كجامعة تكنولوجية. أنا دائما أتكلم عن جامعة تكنولوجية أقول احنا أهل الطاقة في العراق يفترض أن نكون، لأن إحنا عندنا أكثر من 4 أو 5 أقسام معنية بشكل مباشر بالطاقة.
نعم.
إضافة إلى مركز بحوث الطاقة والطاقة المتجددة اللي يعني نمتلكه بالجامعة، واللي هو اليوم يعني أنا قد أكشف معلومة لم تعلن، إنه هو اليوم فاز الحقيقة بيوم العلم، راح تعلن بعد أيام نتائج يوم العلم بالعراق. المرتبة الأولى بمراكز البحوث في العراق هو مركز بحوث الطاقه المتجدده في الجامعه التكنولوجيه.
مبروك.
لكن انا سابدا من حيث انتهى الدكتور. الحقيقه احنا في الجامعه التكنولوجيه لدينا عمل كبير جدا في مجال الطاقه. يعني احنا في الهندسه الميكانيكيه ثلثين القسم يشتغلون طاقه. تدريسين في القسم. قسم الهندسه الكهروميكانيك تقريبا النصف او اكثر يشتغلون في مجال الطاقه. قسم الهندسه الكهربائيه السيطره والنظم. حتى قسم المواد يشتغلون السمارت ماتيريال اللي تدخل في الطاقه. النانو تكنولوجي العلوم التطبيقيه يشتغلون على مجال خلايا الشمسيه وغيرها. جزء كبير جدا من الطاقات العلميه في الجامعه التكنولوجيه تعمل في مجال الطاقه. اضافه لهذا لدينا مركز مهم اللي هو مركز بحوث الطاقه والطاقه المتجدده اللي اشرت قبل قليل انه يتبوى المرتبه الاولى على مستوى البحث العلمي في العراق. كل هذا لم ننتج له اليوم مشروع حقيقي في مجال الطاقه المتجدده. السبب الحقيقه هو غياب التنسيق والتكامل ما بين هذه الاطراف. بصراحه اتكلم، وانا الاخوان في رؤساء الاقسام والتدريسيين يعرفون انه انا اتكلم دائما بصراحه حتى نصل الى اهداف حقيقيه. اهدافنا ان نوصل لها بشكل صحيح. المسؤوليه يتحملها الساده رؤساء الاقسام وساده مدراء المراكز المعنيين، لانه اكو غياب تام للتنسيق فيما بينهم. غياب تام. الاقسام لا تتقبل المراكز والمراكز
دكتور
لا تتقبل الاقسام.
Where is the teamwork؟
نعم.
يمكن امجد يعرف كل الزين معنى التيم ورك.
نعم
التيم ورك.
بروف احنا حاولنا.
The key of success.
نعم.
The key of success is the teamwork.
من استلمنا المسؤوليه وجهنا كتب رسميه وندوات مباشره بضروره التعاون ما بين مراكز البحوث والاقسام العلميه. يفترض الحقيقه ان يكون مركز البحوث هو مختبر دراسات عليا للاقسام، وهذا شيء غير متحقق حاليا. ويسمعوني الاخوان هنا الان هم معنيين في مجال الطاقه كتدريسيين في الاقسام ومراكز البحوث. يفترض مركز بحوث الطاقه ومركز بحوث النانو تكنولوجي اللي في الجامعه التكنولوجيه ومركز بحوث البيئه، هذه هي عباره عن مختبرات دراسات عليا للاقسام. للاسف الشديد ادارات الاقسام يعني خليني اتكلم شوي بصراحه، وجهنا اكثر من كتاب رسمي بدعوه انه الاقسام تدعو تدريسيين في المراكز للاشراف على طلبه دراسات عليا. اخر اجتماع لي مع لجنه الدراسات العليا اللي يمثلها المعاونين العلميين في الاقسام، لقيت ولا واحد مسوي الدعوه هذه. سميت بالاسم فلان وفلان وفلان كتبوا كتاب اليوم الى المراكز، يلا انكتب الكتاب وراح للمراكز. والان يعني ان شاء الله نتامل انه راح يصير اشراف مشترك. الحقيقه اكو تقصير كبير جدا من قبلنا احنا كسيستم في هذا المجال. لو تعاوننا مع بعض التدريسيين في الاقسام مع التدريسيين في المراكز باستغلال الامكانيات الهائله. بالمناسبه مركز بحوث الطاقه مجهز باجهزه في مجال الطاقه الشمسيه صرفت عليها مليارات، وانا مسؤول عن كلامي. صرفنا مليارات من الدنانير.
بس هاي المفروض يعني دكتور لو تسمح لي يعني هو شلون يصير خلينا نقول الريكوجنايز اور ديستنجويش بوست جراجويت بروجكتس. لما عندك مراكز بحثيه تمتلك اجهزه متطوره وتمتلك
موجوده دكتور.
هذه تستثمر لانتاج هاي كواليتي بوست جراجويت.
ولهذا السبب يعني جنابك انا احمل رؤساء الاقسام المسؤوليه قبل مدراء المراكز، لانه يفترض في رؤساء الاقسام يستغلون الاجهزه الموجوده في عند المراكز ويحولون طلبه الدراسات العليا الى هذه الاجهزه، وهذا شيء غير متحقق لهذه اللحظه. يعني حقيقه احنا الان بدنا نضغط ضغط هائل، والضغط هذا يعني بدا يعني احنا ما نشوف جميع مشاكلنا قدام البروف. بس الحقيقه الكثير من رؤساء الاقسام وهذا بداوا يتذمرون من الضغط اللي نوجه احنا كرئاسه الجامعه من اجل التعاون ما بين المراكز والاقسام.
دكتور حيدر، هم الاخوان اللي يديرون المراكز هم مو اكاديميين من الاقسام، هم كانوا بالاقسام
وبعدين من الاقسام
لا ان شاء الله ان شاء الله يعني كلها كينونه واحده. يعني المفروض ينظر الى الجامعه، يعني هاي الثقافه مال الانا والاندفجوال والسايلو ورك، هذه المفروض كلها تنقتل وحده ورا الاخ. التيم ورك is the key for the moving forward. يعني ماكو واحد يقدر ترى يصعد وحده الا مجموعه، واحد ينتج على الاخ يلا يقدرون يصعدون.
هذه حقيقه مطلقه بروف، والان حقيقه احنا بدأنا نعمل على هذا الاتجاه. يعني جنابك شخصت قلت في اخر سلايد، هنا جامعه التكنولوجيا يجب ان تكون، نعم هنا جامعه التكنولوجيا يجب ان تكون، وهذا الشيء احنا مشخصين ونعمل على اساسه. باذن الله هذه الدفعه الان لطلبه الدراسات العليا راح يكون اكو تعاون كبير بين المراكز والاقسام، وان شاء الله راح نشوف شغل اخر يعني باذن الله.
ان شاء الله.
يعني
دكتور حيدر، لو
نعم
تسمح لي لو تسمح لي اقترح، يعني لو تسووها كومبولسري انه سوبرفيجن مال البوست جراجويت يصير جوينت سوبرفيجن، واحد من القسم وواحد من الريسيرش سنتر.
نعم هو الان هذا اللي حصل، طلبت من الاقسام معينه، انا اتكلم بصراحه شويه اكثر. الموجودين الان الشباب اكثرهم ميكانيك وكهروميكانيك، والبقيه من بعض الاقسام. يعني انا طلبت من الكهروميكانيك ومن الميكانيك مباشره، المعاونين العلميين في اجتماع الاخير وياهم قبل اسبوعين، قلت لهم الان تطلعون من الاجتماع تروحون تسوون كتاب رسمي تدعون التدريسيين اللي في المراكز للعمل الاشراف المشترك على طلبه الدراسات، حتى ابو المركز يسمح لك تشتغل عنده وتستغل الامكانيات الهائله الموجوده في المراكز البحثيه. وكرر انا الحقيقه مركز بحوث الطاقه الشمسيه، هسه الاخوان والاخوات التدريسيين اللي اشتغلوا عند حضرتك، كل هذه الاجهزه اللي اشتغلوا بها موجوده عندنا احنا بالمركز بحوث الطاقه الشمسيه، لكن ما حد يقدر ما حد راح.
دكتور حيدر، مداخله بسيطه.
تفضل دكتوره.
طلبه الدراسات العليا يعانون جدا من عدم وجود اجهزه الاستخدام بعملهم، ومن احد يروح مراكز الطاقه يرفضون رفضا باتا، يعطونا استعاره، يقولون انتم عندكم باقسامكم. احنا من نروح
للاقسام. العفو دكتوره.
اي نعم.
عفوا دكتوره، هذه ثقافه توارثناها للاسف الشديد. لو حضرت تاخذين مشرف مشترك من احد التدريسيين في